So, where we have concluded the previous lecture, that is Harvard architecture. So, we're gonna study the next part of this thing, that is, uh, we have seen that von Neumann architecture has problem, that is, uh, programming logic and data are stayed together in the memory. So, it is difficult to scale it out and it's not easy to organize. So, to solve this problem, we come up with Harvard architecture. So, what Harvard architecture do? That is, it separates out from the CPU two memories. That is data memory and there is program memory. So, as we know that address bus goes from it is unidirectional, so it goes to memory only. So, as we have seen in Newman architecture, to that from CPU to memory, the one directional AB bus, that is address bus, goes. So in program memory too, that PMAB means programming memory address bus, and PMDB means programming memory data bus. So yes, so as we have understood in the programming in memory and CPU relationship, that it is unidirectional, it is bidirectional, it is bidirectional, it is unidirectional, and it is also unidirectional, that is DMAB, and DMDB, that is data memory, then data memory data bus. So yep. So from CPU, data memories are separated out and program memory is separated out because it is easy to organize it, maintain it, and scale it. So there is super Harvard architecture, that is, in this architecture there is also a problem, and super Harvard architecture just resolve that it includes a instant cache. There is some data that we use very frequently. So what new Harvard architecture do, that is, it tells to save that reusable information into a cache that's named as instant cache. So yep. Super Harvard architecture is not that important, but to understand the workflow, these three architectures are important and very easy to understand. So there is memory hierarchy, and it is in detailed format, and I will discuss it in detailed format too. But from now on, we are just understanding the workflow of these chapters, and then we gonna deep dive into it. So there is uh, memory hierarchy, that is CPU registers, that is in CPU there is registers with ALU and CU, there is registers as we have discussed previously. So CPU registers, then there is cache means the reusable cache is a memory in which we store that usable information that we use very frequently. Then there is memory, main memory, there is secondary memory, that is hard disk and all. Then there is secondary memory and there is tertiary memory. What is tertiary memory? That is magnetic disks. We will discuss it further, don't worry, just understand this workflow, that is CPU registers, cache, main, secondary, tertiary. So as we go down to the pyramid, the access time is very high. Why it is high? Let's understand with the example. uh, so if the market is far away from your home, let's suppose you are at the top of the pyramid, and if the market is in bottom of the pyramid, you need to travel more distance to get into this memory. So yep, that's why access time is high. It's not the actual reason, but it's easy to remember it. But the actual reason is, if we search something, it first see into the register. If it don't find it, it goes to cache. If it don't find it, it goes to main memory, then secondary memory, then tertiary memory. So access time is high, and as access time is high, whenever the access time is high, the cost is low. Okay, so register has lowest access time, so its cost is very high. Then there is size, like access time is high, then its size is also big. You can see it by the pyramid also. The reason is it contain the more memory. The size is big, so it contain the more memory. So yep, that's why its size is big. So this was the computer introduction, and these three videos are easy enough to make you comfortable with the subject. In the next part onwards, we're gonna deep dive into the registers. So these three videos are generally made for to uh, control your fear, to understand the workflow of the chapter. I guess you have understood the workflow and some basic jargons of the computer. So from the next video onwards, I'm gonna cover this part, that is registers and the different type of registers. So bye.